Today we're going on a bit of a side quest, updating the Hero Jr.'s 12-volt electrical system. Let's start by taking a tour of how it looked when I bought it. It's a combination of the original hardware, additions, subtractions, modifications, and alterations, all relying on two overloaded solder lug connectors. This robot is powered by a 12-volt sealed lead-acid battery stored low between the front wheels. This is an upgrade over the original pair of 6-volt batteries that came with the robot when new. I installed this 12-volt battery in the first video of the series. The battery connects with two lug connectors. These came with the robot, and they are not the right size. These are for 0.25-inch blades, but the battery has 0.187-inch blades. As a result, they're very wobbly. The right ones should be difficult to put on and take off. By the way, the red and blue colors here are not for 12 volts and ground. They're actually a color code for the size of wiring the connector will accept. The red one is correct, but the blue one is way too big for the wire used. We'll need to fix that in our rebuild. Hiding under here are the original battery wires that would have gone to the two 6-volt batteries. They were replaced by the previous owner and just abandoned in place. Under the metal base plate here is the fuse holder. The 12-volt feed from the battery comes here, and on the other side, a single red wire runs up to the computer in the robot's head. The fuse is a 4-amp slow-blow fuse, rated to protect the system from a short circuit, for instance, but slow-blow so it can handle the drive motor starting and stopping without blowing too soon. Up here, on top of the metal base plate, are the two solder lug connectors. The bolts that hold them in place connect the right lug of each one to the robot's chassis, which is used as ground for the entire robot. It's basically wired the same way as a car. This left lug, on its left connector, is the signal from the computer that would be used to trigger the optional alarm wireless transmitter. I've been looking, but so far this particular add-on still remains unobtainium. But we'll want to keep this functionality in place in case one shows up someday. The ground connector here has a white wire going to an aftermarket charging connector that a previous owner added. We'll sacrifice this early on to start testing our new setup. The ground from the original batteries is connected via a solder tab under here, by the way. It's attached to the bottom of the bolt that holds the solder lug in place. We'll reuse this for our new setup. On the right side, we have a bunch of 12-volt connections to this lug from the new battery connection, the aftermarket charging connector, and a line going to the battery side of the fuse. All of this was added by previous owners. Originally, there was nothing on the ground side, but as you'll see in a bit, I temporarily added a wire here for my own interim charging setup. We'll be able to lose this entire lug in the new rewire. So what are our goals here? I want a new, clean power setup that gets rid of all the solder connections and lets me easily add both batteries and external power connectors to the Hero Jr. I'll be using these WAGO 221 electrical blocks, the kind normally used for home improvement projects. And for connecting the batteries and the power supplies, I'm going with these Anderson Powerpole connectors. Let's jump in and I'll narrate as we go along. Let's get started by 3D printing a holder for a pair of WAGO 221 electrical bus blocks. I started with a Thingiverse design, but I kept just the interior space and redesigned a simple shape I can adhere to the robot's chest plate with double-sided foam tape. The print turned out well on my Ender 3 Pro, and the WAGOs snapping into place is very satisfying. Now with the robot powered down and the battery removed, I'll start cleaning out all this old wiring. With the wires removed, I can desolder the bits and pieces. This one was not pretty. I'm going to move the fuse holder to the top of the plate. These are the ground and power lines that feed the robot's head. Time to untangle some cables. Here's the 12-volt line to the computer, which I'll solder to the fuse block. I'm soldering a new ground wire to the solder tab. I'm moving it to the top of the plate as well. This will be our first connection into one of the WAGO blocks. The fuse block input gets a new wire as well. The levers give a satisfying snap, and the hold strength is awesome. Now it's time to stick it in place. Now I'm adding the ground line that runs to the computer. Now let's switch gears from the WAGO connectors and add an Anderson Powerpole to one of our batteries. I'm measuring a very short cable here, just long enough for the connector and a strain relief. This is the Powerpole contact, which fits with the curved section up into the special crimping tool. I'm using 15 amp connectors here, which are the smallest they make. These can supposedly be soldered as well, but the crimp connections look great. The two halves of the housing slide together with a dovetail joint. These springs inside push up on the crimped connectors and allow them to slide past their mates in the other plug. I depress the springs slightly while pushing the wire inward. You can hear them click into place. The battery end of the adapter will get the 0.187-inch blade terminals. This, of course, requires another crimping tool. Again, these are red because of the size of the wire. So I'll shrink wrap the ground connection with black. That's how snug they should be. Finally, a strain relief tab and zip tie to hold things in place. I hate the no-no finger as much as the next person, but this is the correct way to trim zip ties. No sharp edges. I added the same Anderson Powerpole connector to the sealed lead-acid charger. They're genderless, so every connector is the same. Now I can charge the batteries outside the robot. Back to the robot, I'm adding a Powerpole connector for the battery. Any Powerpole fits any other, and they plug together this easily. Now I'm adding a second Powerpole for a bench power supply. With two connectors, I can plug in the battery and then the bench supply, which lets me swap batteries without losing the computer's memory. I haven't had any issues doing these brief overlaps between battery and power supply, but I wonder if one or the other is stressed by it. Finally, I'll reattach this little voltmeter. It's not particularly accurate, but it gives me some idea of where the battery voltage is. And there we have it. I now have the ability to charge the robot's batteries outside of the robot, power the robot with a bench supply to see how many amps it uses with different motors running, hot swap in batteries to disconnect the bench supply, and eventually I can add another connector inside the chest to allow for two 12-volt batteries for extended explore time. Next time we'll hopefully be back to some programming. In the meantime, I wonder what the Hero Jr. thinks about this week's episode.
I thought it was electrifying.
Join us next time as we continue our restoration of everyone's favorite 80s robot. And if you like this video, don't forget to
like, subscribe, and ring the bell.